The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Elisa Baum. I'm Grid Gain Systems Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. First, can you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? And let me see, do I see hands? I see hands. Great. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible. And in addition, I will send a recording of this webinar and the slides within 48 hours after we're done. I would like to introduce today's speakers. We are starting off with Rob Meyer. He's Grid Gain Systems Director, Senior Director of Outbound Product Management, and then he'll be followed by Dennis Magda, who is Grid Gain Systems Director of Product Management and Apache Ignite PMC Chair. Today's topic is building new hybrid transactional operational processing, or HTAP, applications with Apache Ignite. It's part 2 in our best practices series. If you missed part 1, it's up on our website. Feel free to register for that. And with that said, I will turn the floor over to Rob. You have the floor, Rob.
Thank you. And good morning, good afternoon, good evening, everyone. I'm Rob Meyer. I guess we're going to be working outside in. That's just an inside joke between Dennis and me because of our titles. This is part 2 of a 3-part series that we decided to start around best practices with memory computing. We did it because in our work where we talked to hundreds of Grid Gain users, thousands of Ignite users throughout the community, we came to realize that there were a common set of best practices on how people have adopted in memory computing, how they deployed it, and we wanted to start to get those out to the community, to share them and to make them better. So the first step we typically saw people taking, we covered last month. It's to add speed and scale to existing applications because it's the lowest hanging fruit. And what I mean by that is it pays for itself because it basically takes the money you'd normally be spending on scaling up an existing application that's falling down and takes away that expensive hardware costs and some of the additional database license costs and allows you to spend it on an architecture with the memory computing. It gives you more headroom for growth, and it gives you a foundation for what you really want to do, which is not just prop up an application and give it more speed and scale the way it's operating today, but to change it, to improve a customer-facing app, to improve an experience, or to start to change inside operations to improve the end outcomes, partly by doing more analytics and partly by automating some decisions. Now, we call that, when you're making better, doing more analytics of each interaction or transaction, we call that hybrid transactional analytical processing, or HTAP. And that's what we're doing today in part 2. We're going to be talking all about building HTAP applications. It's not necessarily that they're new applications or greenfield applications. It's that once you've opened up all the data and put it in memory that you have, and you start adding all kinds of new data, you get to add all kinds of real-time analytics, which start to lead to better outcomes. What we're going to do after this series is we're going to go into the next step after this, which is about streaming analytics, machine and deep learning, and how you use those to automate and improve decisions even more. So stay tuned for the invitation. We'll be getting it out soon. But in the meantime, I want to turn it over to Dennis, our head of inbound product management and the Apache Ignite PMC chair, to talk about building new HTAP applications. So Dennis, take it away.
Thanks, Rob. Thanks for a wonderful introduction. And thanks everyone who decided to spend this time attending our next part of the series. And as Rob said, whenever you just first you start with acceleration of your existing application, which is low hanging fruit, but now it's time, to move forward, because you would like to invest more in your solutions and technologies and applications, because they also need to reflect the changes that are happening in your market with your business application. And actually HTAP might be something that you have to consider for your existing and potentially future deployments. So what we're going to dive into today. So first of all, let us again to come back to HTAP term, but today to see its main principles. What it gives to us, why actually the market and many companies invented this term, and why now many companies and businesses implement HTAP-enabled applications and services. And after that, as the abstract of the webinar says, we are going to take Apache Ignite as an example of a platform and then database that can power up your HTAP-enabled applications and review the following main components or properties of Ignite that are 100% relevant for HTAP applications. For instance, we are going to look into Ignite's memory-centric architecture, its memory-centric storage, that allows you actually to mix together OLTP and OLAP workloads in your applications. After that, whenever we talk about HTAP or streaming analytics, you have to deal with collocated processing, especially if you have a distributed deployment, a distributed application. And finally, HTAP term is not only about, a mix of OLTP and OLAP. It's also about streaming, because the whole point of HTAP is, to be able to react and process your data and events in real time as fast as possible. And that would include operational workloads and analytical workloads. And also I would encourage us to see what Ignite can give us for on the real-time streaming frontier for HTAP applications. And finally, right now it's not fair to omit machine learning and deep learning topic, because it also becomes a part of HTAP conversations. It becomes a part of many business applications, including e-commerce, including financial industry, and many other sectors. And finally, also HTAP, when we talk about HTAP and when we talk about any other modern distributed platform or technology, we have to consider such a property that is called cloud nativeness. It means that you should be able to deploy your architecture solely and completely in the cloud. And we are not going to talk a lot about the cloud native capabilities of Ignite and of other HTAP solutions, but I would just rather demonstrate you a nice demo. And finally, we are going to have a Q&A section where I and Rob will be happy to answer on your questions. So let's move on with HTAP principles. So the first one, and probably the most primary one, criteria, is that HTAP's goal is to mix or combine several storages within a single one. So the whole idea is the following. Right now, if you want to do operational, whenever you perform operational workloads, you are doing this using one storage. It might be a relational database, or it can be a NoSQL database. But then when it comes to analytical scenarios, when you want to analyze your data, for instance, you are doing e-commerce application and you want to provide relevant recommendations to your customers, like Amazon does, or like HomeAway does, you need to do some analytical, pre-processing. And sometimes you might be going to some analytical database such as Hadoop. And but then when you want to mix OLTP and OLAP workloads, you have to ETL data back and forth between your different storages. And that's becoming a pain in the neck for many business scenarios and for many business applications. And that's probably one of the biggest goals that HTAP is promising to solve for us. HTAP is attempting to combine OLTP and OLAP by storing data in the same database, in the same platform. And there are many, actually, we are going to take Ignite as an example today. But Ignite is not the only one platform our database that is capable of doing this. You can look at other vendors. For instance, you can look at PinCap, another database that also can mix OLTP and OLAP workloads. It's also another good example for you. Next, once you just was able, to mix your OLTP and OLAP workloads, you need to be sure that that platform that is HTAP enabled does everything in a distributed fashion, in a distributed way. Because now, when we talk about HTAP, is assumed by definition that your solution and your services will be scalable. They will be fault tolerant. There will be no any single point of failure. You cannot just rely on a single instance database, right? With HTAP by several reasons. The first one is the scalability issues, and the second one is the capacity. You just, when you deal with OLTP plus OLAP, you're going to store massive amount of data. Imagine just, let's take Amazon as an example again. Amazon for sure doesn't store all the data on a single machine, right? It's just literally technically impossible. And I don't know much about Amazon architecture, but I would just bet that they store all the data in a distributed fashion. And they are capable of doing both OLTP and OLAP. Whenever you go to Amazon website, right? Whenever you'd like to add something to your cart and make a purchase, you still would see a lot of recommendations. Recommendations are coming from the analytical subsystem that combines together machine learning, deep learning, and plus analytical queries. But your purchase, your transactions, that's a part of OLTP. And that's for sure is done using some distributed storage, distributed architecture that powers Amazon e-commerce website. And next thing that also not motivated, but somehow pushed forward by HTAP architectures and HTAP in general is cloud nativeness. I would put it this way. So the idea is that if it was normal, to deploy mission-critical application on premise 10 years ago, now this tendency is being changed. Now many companies prefer to go into the cloud, and here we are not talking about public cloud deployments. Many cloud providers like Google, like Microsoft, Amazon, Oracle, etc., they give you a way to deploy private clouds, managed services. The idea is that you want to outsource a lot of, you don't want to host your own infrastructure. It's easier and more affordable to pay for someone else for that. And here is, and also according to analysts who predict that by the next, by 2025, 2030, there will be much more deployments in the cloud than on premise. So this is why whenever you go with HTAP, it's also good to confirm that your HTAP platform that is going to power up your application can be deployed and managed directly in the cloud. So those are like three main principles of HTAP, or main three driving forces that motivate or encourage many platforms and databases to to state that they can run and they can support HTAP enabled applications. Now, as we said, let's take Apache Ignite as an example and review what Ignite does, what Ignite can offer for HTAP segment. So that's like a very known slide about Apache Ignite. I do believe that many of you who are on the call today have seen it multiple times. But today I'm not going to review all these components over here. If to recall the previous slide, if to think about it, you should get that HTAP imposes you to have a lot of different capabilities if you want to support everything within a single platform. If you want to do OLTP, you need to have transactions. Ignite has it. If you want to do OLP or OLAP, you also need to have SQL or some advanced analytical capabilities, such as advanced SQL queries or machine and deep learning. Ignite also has it. If you want to do streaming, real-time streaming, which is also essential for many HTAP-based applications, you also need to have some streaming components within your platform. Ignite also goes with that. But when we talk about storage, yeah, the first principle of HTAP that we covered previously, the storage is essential here. It has to be distributed. It has to be able to process data as quickly as possible. And this is why Ignite can offer you its own memory storage. And also, when we talk about, and specifically about analytical workloads, it doesn't make sense, to store all the data in RAM. This is why many in-memory databases who don't use disk as an active storage are not applicable for HTAP workloads, because many in-memory databases that exist in the market require you to preload all the data in RAM. But who would do this? Who would try to preload all the historical data in RAM? There is no any sense in this. And when we talk about HTAP platforms that can run HTAP applications, you need to be sure that disk can be your active storage that can store all the data you have in your applications, and memory will be your sort of caching layer that can store all the data you have or can store a subset of the data so that you can accelerate some of the OLTP scenarios or some lab scenarios for your applications. So that's like from the high level perspective. Now let's drill down and review most major components that are required for your next generation HTAP application. And we are going to start with Ignite Memory-Centric Storage. So here is, we're not going to spend a lot of time, but the whole point of Ignite Memory-Centric Storage is pretty simple. Both memory and disk are used in Ignite as active data layers. It means that you can store the whole copy of data in RAM and do not have disk at all. Or you can store the whole copy of data on disk and just cache a small subset in memory. It all depends on your configuration parameters. And what it gives you with Ignite, as with an HTAP platform, you can store petabytes of data on disk, and for instance, gigabytes in RAM, subset of gigabytes of data in RAM. Or you can store gigabytes or terabytes directly in RAM and both on disk. It's up to you. There are no any limitations. It's like a really flexible component. And also, as we said, disk is an active layer. It means that even if your whole Ignite cluster shuts down, you don't need to preload all the data back from disk to memory after this happens, because once your cluster is assembled back, you can start issuing your workloads right away. The data will be taken from disk without any issues. But with Ignite, guys, in general, the platform is pretty complex. I mean, that's not complex in terms of different components and features. And we decided, to simplify one of the parts for you and put together the main memory usage modes for Ignite. So just to recall, this Ignite memory-centric architecture, first, how can you use Ignite? You can use it as pure in-memory solution when the data is not stored on disk at all. All the data is stored solely in RAM. And the benefit of this scenario is that you are getting the fastest performance possible with Ignite. Yes, this use case might not be applicable for HTAP, when you sometimes need to preload to keep all the data on disk, but that's just for your reference. The next scenario, the scenario that we're discussing and covering during our previous webinar a month ago, when we were talking about acceleration of our existing applications. And here is Ignite can be used as your caching layer above your existing third-party database. And as far as you remember, you just need to deploy Ignite, slide Ignite in between your applications in your persistent database. And after that, Ignite will accelerate all your read operations. And you will be able to scale out your Ignite cluster and scaling out your read workloads. That's also like a wonderful solution. And this is when Ignite is used as a memory data grid. The next two Ignite usage modes are something that is totally interesting for HTAP workloads, for HTAP scenarios. The first one mode is called in-memory plus full copy on disk. So in this scenario, it's assumed that the data is stored both the whole copy of data is stored both on disk, in RAM, across thousands or hundreds of your machines in your cluster. And with this scenario, what you're getting, the difference from the previous one, when you accelerated, let's say, a relational database, here is you accelerating both reads and writes. And also you are getting fast restarts with your Ignite-powered HTAP solution. Why so that? Why fast restarts? As I mentioned a couple of minutes ago, since disk Ignite native persistence, here is we are using that persistence. If your cluster is restarted, there is no any need to warm up your memory. We store all the indexes, all the data on disk, and you just need to activate back your applications, and you will get all your queries executed without any issue. And final mode, which is my best option, that shows that Ignite can be as flexible as possible, is that it means it's named 100% of data on disk and plus memory cache. Here is it assumed that, again, you use Ignite native persistence. All the data, without any exception, is stored on disk, and we are caching as much as you want or as much as you can afford directly in memory. And in this scenario, that's an excellent choice for your HTAP applications. Because for HTAP, for instance, we might have several SQL tables that store data both on disk and on RAM, and you use that memory configuration for your OLTP workloads, for your operational workloads. For instance, Amazon might use it, to do transactions with you, to transact you, to charge you for something. At the same time, in the same database, in the same platform, you might have a little bit different memory region, where you store again all the data on disk, but only 10% of data in RAM. And that memory region might be used for your OLAP workloads. And for instance, if you take Amazon as an example again here, Amazon can use that for its machine learning algorithms or for advanced analytics. When Amazon decides which book or which purchase to recommend you when you land on its site again. So, and the benefit of this approach, which is good for HTAP, it gives you read performance, improved read-write performance, depending on your memory configuration, fast restarts, and you can go beyond RAM capacity. You're no longer stick to RAM. You are free to use RAM, but you can use, here as you're using disk as your primary storage. Well, that's the storage. Let's move on. Now we know, so actually we solved and we supported the first HTAP principle, which says we want to mix OLAP and OLTP workloads within a single platform or database. What's next? Once we did this, once we decided that this is how we would configure our distributed storage and platform and how we would arrange our memory regions, we need to move forward, and we need to see how else we can improve our applications. And here is we need to talk about collocated processing. Collocated processing is an interesting concept that is actually related to many distributed databases and solutions. Here is Ignite is not unique. We can take products like Google Spanner, CockroachDB, PinCap, VolDB, Memoscale, and many other databases. Why all those databases are becoming so successful nowadays? Because they give you two things. They enable you to run distributed SQL queries, transactional SQL queries, and also you can run them efficiently. That's an important point. So imagine that you're having your relational database that is distributed. And all those solutions, all those databases that I listed, they rely on affinity collocation. It might be named differently from one product from another, but the point is the same. What affinity collocation gives you? First is data-to-data collocation. All the related data that you have in your system, in your application, can be collocated. For instance, countries and cities. What you can do here, but by doing simple, configuration with Ignite or with any other distributed database, you can make sure that all the cities that are located in the United States are stored in the same cluster machine, which would allow you to run complex SQLs with joins that need to join data as related to countries and their cities. The same is for vendors and cars. Like if you want to store all the cars that were produced by specific manufacturer in the specific country, you also can collocate this data easily by configuration, and then you can run efficient SQL joins. And that's natural. Why it's so important? For sure it's important for SQL in general, but it's also important for HTAP. Because with HTAP you're going to do, for sure you're going to transact, you're going to do LTP, but also you're going to do analytics, right? And usually when it comes to analytics, you're preparing pretty complex SQL queries. And the more data is collocated, the faster your analytical queries and the faster you can respond to changes that are happening with your business application. And the next step, so that was about data collocation. That's the first step you need to ensure that happens within your system. The next step is compute to data collocation. On the next slide, we're going to see, like, we're going to, review the existing approach, how we process our data, and how we process the data with collocated computations. But the idea of compute to data collocation is that instead of getting data from our database or our storage, bringing it to the applications, we can write a calculation, send this calculation to our cluster nodes, execute it there, and then get back a tiny small result set. And what does it give to us? It significantly drops down the amount of data you transfer over the network back and forth. And as you guess, the less data you move around your applications in your cluster nodes, the better its performance. It's obvious. So now let's briefly look at these two different approaches. The first one that is to the left of the slide, so-called classical client-server processing. Here is, take any existing SQL application when you deal with relational database. Probably that's the simplest example I can give to you. Whenever you would like to update any data, first you're going to select it, right? Select will return you something, return you a result set. It can be small or it can be big. Then you're going to update this data. Probably you would like to analyze what happens with this data, then you need to write it back. In this scenario, and like it's shown on this slide, right? First, you are sending this request, you're getting back the data, you're processing it here, and you're moving it back to your server nodes. And this is how you saturate your network. And I have nothing against this approach, because even with HTAP workloads, you still will be using SQL queries, you will be using some machine learning computations when you will be moving data from your applications, from your storage to your, moving data from your storage to your applications. But also we have to consider, whenever we decide to add new functionality or new processing unit to our application, I would consider collocated processing first. The idea with collocated processing is a little bit different. Here is, we decided we don't want to move data from our storage to our application, and we created some simple calculation. It's just our piece of code that is sent to our cluster nodes, executed there. Probably you might want to iterate whole data set that is stored here, and then you're going to get a final result set back. So the benefit lies here. You do not move data over the network. You're just getting back a final tiny result there. And if you recall, what is another product that does the same? Big data, Hadoop, MapReduce concept. Hadoop became, a dominant product for big data applications and scenarios, because in addition to its HDFS distributed file system, it empowered us with powerful MapReduce paradigm. And collocated processing is the same MapReduce-like paradigm, which says that instead of getting data from Hadoop, bringing this data stored in your massive Hadoop cluster and doing something with this data on your application side, we can do a reverse operation, right? We can just write some calculation. Calculation will be sent to our Hadoop nodes, does all the manipulations with the data there, and brings us back a result set. The same is true for fast data. The same is true for Ignite, and the same is true for other storages and platforms that can be used to power your HTAP applications. So that's about collocated processing. And finally, as for the joins, right, as for the SQL, SQL also benefits from data-to-data collocation. So I do remember that we shown this slide during our previous webinar when we were talking about SQL capabilities that are needed if we just deciding to accelerate our existing applications. But here is the point is a little bit different. Actually, this slide shows how many distributed SQL databases solve the problem of SQL efficiency. Once you distribute your data, once you collocate your data, like it's shown here, all the Canadian cities are stored on one node and all the Indian cities are stored in the other node. Then you can run pretty standard SQL queries with joins and don't worry about SQL performance. The join will be executed over here and your application will get just the final result set. No any data movement between the cluster nodes. No any data movement, significant data movement from your server nodes to applications. The join happens locally. You're just getting result set. This is what we actually need for HTAP, right? Especially for both for LTP, for LP. And this is what Ignite, as many other distributed SQL databases, provides you. So just consider this. Final thing, wonderful. So looks like when we talk about Ignite, actually it has first two things that are required for HTAP. It has memory-centric storage that is capable, to satisfy all your LTP and OLAP workloads, and also it empowers you with powerful collocated processing concept that will help you to optimize your workloads and boost your overall performance. But the next thing that comes to my mind is the real-time streaming. Because if you read some different materials and articles on HTAP, how this, where this tendency goes, what happens, how this HTAP concept is being applied and adopted in different companies, you also hear the real-time streaming, streaming analytics term again and again and again. And so now let's see what Ignite can give you for these scenarios. The real-time streaming is pretty essential. Why do you need it? For instance, let's take today we decided to take Amazon, right, as an example. Amazon for sure runs a lot of machine learning and deep learning to give you personalize your experience with Amazon, to be sure that you're getting relevant recommendations. And just believe me that all those machine learning models are being trained iteratively. They're being constantly retrained, and all those algorithms are being redeployed just on the fly. And how can Amazon do this? It's in real time, might stream all your interactions. What do you do? What do you search? What are your interests? What are your preferences? All this information gets to Amazon. It's being processed by its machine learning algorithms, and the overall experience of your interaction with Amazon is being improved constantly because everything happens in real time. The changes are streamed in real time. The data arrives in real time, and this is why your experience improves, from every minute, from hour to hour when you go to Amazon. So what we have with Ignite. Ignite actually provides actually for this, when it comes to streaming, you can use Ignite as a storage for streaming pipelines. What does it mean? Again, it means that Ignite can easily accept endless streams of data, giving you a way to process them in real time. The endless stream of data can come from any streaming product. For instance, here is on this slide, that Apache Ignite belongs to Apache Software Foundation, and we decided to list just few Apache ASF members of Ignite, such as Kafka, Flink, Spark, and Storm, that are well integrated with Ignite for streaming purposes, particularly. So you can just stream your data from all these products to Ignite. You can pre-process the data before using Spark or Kafka, and then push it back to Ignite. It's all possible. And actually, these kind of integration allows you to mix different open source projects together and do streaming analytics at scale. And then once you do this, you can retrain your machine learning models. You can run your LTP, OLAP workloads, the same system, the same storage. That's actually something that excites me specifically about HTAP and how and what it can give to our OLTP and OLAP workloads. If to talk about Ignite plus Spark, to briefly talk about that integration, we know that Spark is used a lot for streaming and for machine learning. Here is Ignite has probably one of the best integration with Spark in the market in general. Not only because we just belong to the same foundation, but just because we literally believe in Spark. We found it's like a pretty useful and handy tool for streaming in machine learning. And with Spark, when you use Ignite as your storage for Spark, which also relevant for your HTTP application, you can have a single storage Ignite, and you have another application that does some, little bit of analytics using Spark, and uses the data, different data sets stored in your Ignite cluster. You can use Spark RDDs, you can use Spark data frames. And when you do this, Ignite will make sure that Ignite also tries to empower collocated processing concept. When you run any RDD-based calculation or data frame as a query, Ignite will try all its best to run that query in place in Ignite, not moving data over the network, not to bring down your performance. This is something exceptional about Ignite and Spark integration. So our main goal is to make sure that Spark calculations are executed in place in Ignite whenever it's possible. So, and this is one of the probably biggest benefits of that. And finally, so nowadays I've already given a lot of examples on how Amazon might analyze your interaction with the marketplace. And for sure, today we see that even companies of smaller size, businesses of smaller size, we all start, applying machine learning techniques. Yes, there is a part of machine learning that probably, just being developed and done by big corporations like Google. They do all this machine vision, then self-driving cars, etc., etc. That's not just something that will be adopted by massively by business. But when it comes, to basic machine learning tasks such as fraud detection in financial industry, such as personalization in e-commerce, and such as logistics in transportation, all those businesses are adopting machine learning and deep learning nowadays. There is a business need, and there is a need for a storage or a platform that is capable to run machine learning applications in training, preferably over the same data that is used for OLTP, OLAP, and streaming. You see what I'm saying, right? So we're trying to merge. OLTP, OLAP, streaming analytics, which includes not just advanced SQL queries, but also machine learning and deep learning. So let's see what Ignite gives you on that frontier. So first, why we have Ignite, why we've added machine learning to Ignite, and why we are sure that it's required for HTAP and for other business use cases. First, distributed storages, distributed databases initially tried to solve one of the biggest challenges. They wanted to make OLTP and OLAP scalable. And now Ignite also wants to do the same for machine learning workloads. We want to be sure that it's possible to train your machine learning model across a cluster of machines. We want you to go beyond a single node capacity. Because if to put aside TensorFlow, right, then most of the well-known machine learning frameworks, they're designed to work with a single server unit. So you have to run your whole algorithm. You will be able to run your whole algorithm only if you can feed all the data within boundaries of a single machine. Also, it means that with that massive scalability, we want to support horizontal and vertical scalability, which means that for machine learning, it's exactly essential to use that Ignite memory mode when you can define a special region for machine learning data where all the data is stored on disk and you cache as much as you can in RAM. That would be your scalability across RAM and disk. And also then you can scale out. That's your horizontal scalability. Finally, Ignite empowers you with so-called zero ETL concept. Because nowadays, if you look at different machine learning frameworks, sometimes you need to train model using one data snapshot, which is stored in one storage. Then once that model is retrained, you need to deploy this model on your operational data store. And again, you're moving data back and forth over different storages. That's not something that HTAP is trying to solve. And with Ignite, you can train the models and you can update the models within a single storage. Again, the same storage, the same platform, but just different API. Fault tolerance and continuous learning, again, is just a continuation of what Ignite delivers for the rest of the APIs. Even if your training of your machine learning failed, it doesn't mean that you have to retrain it from scratch. You can start from that point when one of the nodes went down. And actually, that functionality is based on so-called partition-based dataset that are available in Ignite. Just to give you a little bit more of technical context, how it works in Ignite. Here is, for instance, we have two nodes clustered in Ignite. And in addition to data that is distributed, some raw data that you want to use for your training is stored again in a distributed fashion. It might be stored close to your operational data, to your transactions, accounts, but it doesn't matter. It's just some memory region that stores raw data for your machine learning models. In addition to data, these yellow blocks, you have context that stores present status of your machine learning training process, which means that then when you have your client application that receives, for instance, some real-time updates from your application, that something has changed. For instance, Amazon might apply the concept like this. I might be oversimplifying, but anyway, if something has changed in your interaction with Amazon website, Amazon might trigger update of its machine learning model. It will feed another data, then it will restart the training, and the training will happen in the background. If one of the nodes goes down, the data most likely is not stored, because here as we simplified the thing, we have on the two server nodes, but in general you will have much more. The data will not be lost, because most likely you stored a copy of the data in the other node, and the same would be true about context, which means that the training part will continue without any issues. And this is how it works. And this is the same thing. So what we are doing, we are adapting the same concepts such as data distribution, affinity collocations, collocated processing across all our APIs. So basically, whenever I talk about Apache Ignite, and the two major things that you need to keep in mind, first, it's Ignite's memory-centric storage, which is really flexible, as you now see, and rich APIs that are well integrated with that storage. Our benefit over probably other solutions is that we are well integrated with our storage. We are not using a third-party storage. And finally, a cloud native. So deployment of our HTAP application. Our HTAP application, as I said, it's up to you for sure. Usually, if some of the platforms of like Google Spanner, they are designed to work with cloud due to their architectural specificities. But there are other databases like, let's say, CrossDB or PinCap. I think you can deploy them both on premise and in the cloud. No limitations. And this property is really essential for many businesses, because many companies start using cloud, private clouds, public clouds, it doesn't matter. And you need to be sure that you provide you might provide both cloud as a deployment option and some managed service facilities there. So today what I'm going to show a quick demo demonstrating how we can use GridGain Cloud to deploy our first distributed cluster that might be used for your workloads. And I'm going to demonstrate how we first going to distribute the data, how we're going to collocate this data using data-to-data collocation, right? Recall that Affinity Collocation slide. And after that, I'll show how to execute distributed SQL queries with joins. So finally, And the whole point of this thing is that to show how it's simple to start with, GridGain, which is an enterprise version of Ignite in the cloud, which will be managed for you. So like before this webinar, like 1 hour, 30 minutes ago, I started my 4 nodes cluster that is already up and running. So presently we are deploying Ignite on AWS. So let me see that my cluster is stable. It's fine. So I went to monitoring tab. So now I should see all the information. So that's my total heap size. I'm using micro instances. So some information about memory. These are my cluster nodes, different memory data. So nothing is used. So we don't have any caches, or also known as tables in Ignite deployed there. So now it's time to preload something to our database, to our storage, right? So let's go back to the clusters. And here is GridGain goes with a nice wizard that demonstrates how to start. First, we need to download so-called GridGain Cloud Client Pack that is used to connect to our database. I've already did this. You need to download your personal SSL certificates, which is pretty simple. And also then after that we can connect. Here is it suggested us to use SQL interface. So I'm not against of this. So I'm just going to copy paste this command that is predefined automatically for me, for my cluster that is available on this address. So let me go to my terminal window. Let me make this window bigger. And now we're going to downloads GridGain Cloud Client Pack. So let's see what we have in here. So I want to go to bin directory. So in here is I already have my key store. So I've downloaded it before the webinar. So I can connect to my cluster securely. And here is we're going to use SQLite tool that is shipped with Ignite. And now I just, as you see, I've copied this connection string from the cloud. So hopefully I will be able to connect to my cloud. We'll see. Oh, wonderful. So I could connect to my cloud. So now I'm just connected from my local laptop to the cloud, to GridGain Cloud that is managed for me. So let's see. I just want to be sure that there is nothing deployed, so I don't have any tables. And now let's follow the next part of my command. So here is we are suggested to preload the first data. And actually this command supposes that this file is stored in this directory. So that's actually true. If we go to the directory where this is located, examples, SQL, here is we have this file. So I'm going to open it because while the data will be preloaded, I want to show you the content of it, because it shows you how we apply affinity collocation in practice in Ignite. So text edit, I will use that simple editor. So now let's bring it. So first thing, we are preloading the data. Okay, we created a table, and now the data is being preloaded from my local laptop to my cloud. While this happening, let's see at the structure. Here is we have simple create table commands, nothing unique, right? If to talk about other relational databases, but here is an interesting parameter, affinity key for our city table. So affinity key refers to country code field of city table, and primary key of city consists of ID, city ID, and country code. So what's the point of affinity key? Affinity key, this simple affinity key parameter, enforces the affinity collocation, data-to-data collocation between country and city. Country is supposed to be a primary, kind of a parent entity, and city is a child entity. It means that now whenever we are going to insert or update any cities with the given, with some ID and country code, all the updates will go to the node where country with the given ID is stored. So that's the idea. So it will make sure that all the cities that have the same country ID are stored on the same node where the country with the same ID is located. So that's the whole idea of affinity collocation. And that's all you need to do on your configuration side. Because when we were talking about affinity collocation, it might have sounded scary, right? But in practice, all you need to do is just, to put together some parameters in your create table commands, for instance, if you use SQL to interact with Ignite. That's it. And after that, when you're going to insert all this data, you don't need to do anything else. Ignite will distribute the data following your affinity collocation automatically. That's all. That's the point. Okay, so that's enough. So now I see that the data was preloaded. Yeah, let me see that the tables are there, so I can run. So from city, right? So yeah, we have a lot of different cities. Good. Now what else we want to do? So there is another query. So this query returns select name and population. Let's run it. Copy and paste. So those are the most populated cities. I don't know, just some populated, some cities. Okay, simple query. What else I want to show you? Let's first go to the monitoring tab. Back again. Let's see what we have here. Now we should have some data. Yeah, we created caches or tables. It's all the same. The data set is tiny for now, but it's just solely used for the sake of this demonstration to show you how it's simple to preload the data and to work with your, HTAP-based storage deployed in the cloud, and you just, interacting it with from your local laptop. That's what I'm doing right now. And now let me run a little bit more advanced queries. So we've already, so this query, again, here is we are going to use SQL notebooks that go with GridGain Cloud. So the first one returns us the most populated countries in the world. It's not surprising that China and India are the most populated countries in the world. Then we have United States. But what else is interesting? Now we know that we could collocate the data, right? We know that all the cities are collocated with their countries, which means that we can run pretty complex joins. And there won't be any data movement. So now, if I run this join, I will see that the most populated cities are Shanghai, Moscow, and New York. So the data might be a little bit outdated because that database snapshot, I don't know how many years, how old is it? But anyway, so this is how it was at least a couple of years ago, several years ago. And then for sure you can run simple updates, deletes, and inserts. So that's how HTAP, how like platforms and storages that can be used for HTAP provide you with that cloud nativeness property. So that's actually probably one of the, so when you work with the cloud, you can choose any cloud you want, deploy it there, or you can use different marketplaces, or the final step, it can be your cloud as a service. This is, for instance, what we demonstrated here today with GridGain Cloud that can be used even for your Ignite application. So you can deploy GridGain Cloud here and connect from your Ignite applications that use Ignite binaries. So we used SQL, but also then you can use Java, you can use .NET, you can use Ignite thin clients, GridGain thin clients to connect to your cluster deployed there and use. You are not stick to SQL APIs only. Finally, so we are approaching the end of our presentation. Actually, we are done with the overall review. So just to summarize, just a short upshot. First, HTAP. HTAP is one of the big promising directions of our technologies, which would empower many applications and solutions with powerful platforms that would be able to mix together OLAP, OLTP, and streaming workloads within a single storage, within a single platform. Above that storage, you should be able to have rich and flexible APIs that might support your OLAP use cases, OLTP use cases, your machine learning, and etc. Also, finally, by definition, HTAP is based on distributed solutions, on distributed platforms. which because it's hard, it's impossible to scale horizontally. And this is why whenever you start new HTAP powered application, look for a platform that satisfies all those main HTAP principles that we covered before, because that's actually a wonderful thing to invest into. As we started with the first part of the series, it's totally wise, and I always support, appreciate if people start, with the acceleration of existing solutions. But then you also, as many other companies, you need to think about your roadmap. And as for the roadmap, think about HTAP or, greenfield applications that require something else that will meet all the challenges and demand of your future customers, of your future workloads. Just recall many examples we put together. Recall Amazon, recall HomeAway, recall Workday, recall Barclays, Bank of America, American Express. All those companies have started implementing HTAP for their solutions and applications. And it might be required for you to do this earlier or later. So probably it makes sense to act here proactively. So that's it. Rob, I'm happy to answer any questions.
All right, folks. Well, hopefully you can hear me. Can you hear me, Dennis?
Yeah, I can.
Okay, well, we've had a few questions. So curious, I guess the first one I'd ask is, how do you think about, or where do you start to look for where you start with HTAP? What kinds of applications typically come up with companies where they decide, okay, I'm going to go ahead and start doing some real-time analytics or something like that?
Yeah, so it's
what like your advice.
Yeah, so it's a wonderful question. So today we took Amazon, which is one of their examples from e-commerce, right, from retailing sector. So those companies for sure, they combine both operational workloads that charge you for your transactions purchases with some analytics whenever they want to personalize your experience, your interaction with those solutions, when they want to provide you with the right recommendations. The other industries are for sure the financial one. Financial sector guys are really innovative. For sure we heavily rely on them because everything is purchased with credit card or debit card nowadays. And to ensure that those companies, if they want to ensure that the payment is not fraudulent, they also run analytics in background. And now they want to do that analytics in real time. And now we see even dealing with a small part of those companies within Ignite and GridGain, we see that those companies are adopting a lot of OTP and OLAP and HTAP concepts in business. Another example might be transportation industry, logistics. For sure, there is always an operational piece in your interaction. Like whenever you go to a website, you order some, delivery from point A to point B, but also then the company needs to figure out the best route to deliver, thousands of different packages and parcels across country or continents. And they also prefer start looking, kind of at HTAP-like solutions where they mix together OTP or LAB within a single platform where they apply collocated processing and machine learning. So those are just a few examples from 3 different industries.
Okay, so it's basically one place to look is a customer-facing app where you need a real-time decision with a customer that's going to improve the experience. Like, I think HomeAway, an example, is all the pricing they do on the fly. But in general, just any kind of analytics that could be personalization, that could be pricing, that could be assessing risk or doing even a credit check on the fly to make the process faster. And the second example you gave was around operations, where you have to make some kind of, where making a decision on the fly can lead to a better outcome, like an SLA in logistics. where you have an end goal of trying to get a package to a certain place on time, and you might be able to make better decisions on the fly at each point in the supply chain.
Yeah, totally agree.
Okay. What are some of the easiest types of analytics to think about that you've seen across these use cases? Are people just, using SQL? Do they end up writing code? What are some good examples there that people should think about?
Actually, Rob, don't you want to answer this question? Because I think that you would be able to provide us with wonderful examples. Because I know you. Yeah, so like.
So wow, that's putting the interviewee on the spot. So I guess for real-time analytics on the customer-facing side, there's often a lot of personalization where you're watching as the person's browsing, you're deciding what to show to them. So Amazon's a very typical example of when they promote to you. I think Netflix is actually a less real-time one. And I think something like Amazon is even better where they're cross-promoting. I think the advertising industry is really interesting as they retarget while you're browsing around. But let me flip the question back to you because you need to be able to do that as an interviewer. When do you know, as you're taking in all this information to make these decisions, that you've kind of hit the wall with how fast you can ingest the data that you need to make these decisions, or move the data around to make these decisions? When do you know that your existing database or way of moving data around has hit the wall? What are some typical rules in your head where you kind of say, well, if you're going to do that kind of personalization or calculation, you're probably going to have to change how you move your data and how it's stored?
Yes, so here is as we discovered during our previous part where we accelerated existing deployments. Actually, we accelerated, we boosted our read workloads. We actually boosted probably one of the piece of your whole infrastructure. We might have boosted your OLTP applications or analytical applications by caching data in the realm with Ignite. But here is again, this question is about a little bit more complex thing. You still, if you do, let's say, personalization separately from your, let's take Amazon, right? You have a single web, so you as a customer comes to a single land on specific site or website, right? That's a single application that you interact with Amazon. And technically, if you use different deployments to do personalization and transactions, for you, it might be harder, to process it, because the data might be ETL'd back and forth between the databases, between the data storages. And if you see that the ETL piece becomes a bottleneck of you, then it makes sense, to consider HTAP. It makes sense to see how can we combine OLTP and OLAP within a single platform. Next part, which is also separates, simple memory caching from memory-centric database or HTAP application, is that whenever you need to boost your writes, because if your application is write intensive, then simple in-memory caching will not solve your write problems. So the write still will be your bottleneck. But as we discussed with Ignite today, Ignite is one of the options. If you use Ignite memory mode, when Ignite's persistence is enabled, then you're boosting both reads and writes. And final thing, also, we all speak about the speed and scale. We also, when we were discussing, we were talking about in-memory computing in relation to the acceleration of existing applications. We omitted a question of, downtimes. Yes, you can accelerate your existing relational database or NoSQL database, but what happens if your whole cluster goes down? Once you restarted your cluster, you need to bring up data back to memory, and the downtime might be not applicable for your use case. Recall Amazon again. I do remember the time, like a year or so ago, when Amazon just went for 10 or 20 or so minutes, and Amazon lost millions of dollars because of that tiny downtime. And this is why your HTAP-based platform should be able to recover from a data center downtime just as soon as possible. And it means that even once you recover all your hardware, you don't want to wait while your terabytes or petabytes of data are brought back to memory, right? Because you're still losing the money while your application is done. So that's another thing to consider: fast restarts or instantaneous restarts when you want to look at HTAP scenarios.
Perfect. Well, I think we've run out of time, but if you have any other questions, feel free to reach out on the Ignite forum or Stack Overflow. People are watching and they're playing people with some great answers. I want to thank Dennis for all the information. It's been a great conversation. It's been some great conversations in the questions area. So watch out for the next invitation for part 3 of the series, and feel free to send us questions. They can always lead to new webinar topics or blogs or posts. So with that, thank you very much, everyone.